Okay, so today we're going to talk about solving radical equations. If you follow these 4 steps, you're guaranteed to get it correct. So step 1 is we want to get the root or exponent alone. So whatever's being raised to that power, if you have an exponent, whatever's under that root, all of that needs to be by itself. Then we're going to raise each side of the equation to a power to remove that root or exponent power, the rational exponent. Then we are going to solve for x, and we double check for what we call extraneous solutions. So extraneous solutions are solutions that we get out. We do the right math, but it doesn't work if you plug it back in. So looking at this first problem, if we start with the first thing, we want to get the root or exponent alone. This is our square root and everything under it. We want to get that by itself on one side. So right now we got a 2 up there. What should I do with that 2? Correct. We're going to minus 2 on both sides of the equation. So now we have a square root 3x minus 2 equals 4. So we minus it from the left side and right side, keep it balanced. Now, step 1 is done. We've got the root by itself. So step 2 is to raise both sides to a power to remove that root. So what's the opposite of a square root? 2. It's a power of 2. So we're going to put a power of 2 on both sides. So on the left side, you're going to get rid of that square root. And on the right side, you just square the number. What's 4 squared? 16. Now we have a quick equation that we can solve for x. So what would you do to get x by itself? And then last, so x equals 6. Now, once we solve for x, we got to do step 4, which is double check for extraneous solutions. So when you double check, I usually just put DC, is you plug that number into the equation and see if the left side equals the right side. Now, you can use your calculator to help you out with this. You can type all this in exactly how it looks. Make sure that square root continues over as far as possible. So if we wanted to type it in, we would have 2 plus the square root, 3 times 6 minus 2, and that should equal on the right side, which was 6. So make sure that those equal out with each other. Take that. All right, and as long as they equal out, then you're good to go. So that worked. Check. All right, let's do problem 2. Now, think about your steps. So I'm going to pull this back over so that way we can see it a little bit. It's kind of going on top of that other problem. But step 1 is to get the exponent or root alone. So this time we have an exponent. What's being raised to that exponent is everything in the parentheses. So we want to get the parentheses and the exponent by itself. So there's a 2 in front. We got to get rid of that 2. How do we get rid of that 2 now? We're going to divide by 2 because that 2 is multiplying, so we divide both sides to get rid of it. So 50 divided by 2 is 25. Now we have that part by itself, the parenthesis and exponent. So now we're on to step 2, which is raise each side of the equation to a power to remove the root or power. So this is where you might want to go and add some notes. You can add it to your steps here, or you can add it here. To get rid of that power, we use the reciprocal. Does anybody know what the reciprocal is? It's kind of the opposite. So the opposite of 2/3 would be 3/2. So the reciprocal is when we flip the fraction. So we're going to raise both sides to the flip of that fraction using the reciprocal. And if you need to write more after reciprocal, you can write flip fraction. And that way you know what that means. So we're going to raise both sides to the 3/2 power. So what that does on the left side is it cancels out that fraction. Because 2/3 times 3/2 simplifies to just 1. If we were to multiply them together, it'd be 6/6, which makes 1. So on the left side, we're just left with x minus 2. On the right side, on the right side, we can just type that into our calculator. 25 to the 3/2 power, or you can use your math skills. What is 25 to the 3/2 power? How could we rewrite it as a radical? It's the square root of 25 to the 3rd power. Square root of 25 to the 3rd power. So what's the square root of 25? 5, and 5 to the 3rd power is 125. There is something extra that we need on problems like this. And you might remember it. We're actually going to do it a bit more in the next unit, but you might remember it from Math 1. When you square root a number, you have to put plus or minus with it. Anytime you do an even root, you have to put a plus or minus. Because if we square something, if we square -5, we get positive 25. If we square positive 5, we also get positive 25. So this is an extra little note that you need to add. Put plus or minus if you take an even root. Remember, the roots are on the bottom, so if that bottom number is even, you have to put a plus or minus with that answer. So this particular problem is going to end up having 2 answers because of that plus or minus. So we're going to end up with x minus 2 equals 125, and x minus 2 equals negative 125. So you end up with 2 different answers if you have that even root. Now, what would you do to solve those equations for x? So we're going to add 2. So x equals 127 and x equals negative 123. So an even number, so 2, 4, 6, or 8. So if that bottom number is even, then that's an even root, because it would be a square root, a 4th root, or a 6th root. So anytime that you have an even on the bottom, not on the top, just on the bottom. All right, so now we're on to step 4, which is to do what? Double check. So let's double check these answers and make sure that they're correct. So we have to double check both of them. So on this first one, it's 2, and then in parentheses, 127 minus 2 to the 2/3 power. We want to see, does that equal 50? And then over here, we're going to do the same thing with negative 123 and see if that equals 50. So let's grab our calculators. we have 2. 127, was it minus 2? And then to the 2/3 power. So that's our original problem, just replacing x with 127, and it should equal out to be 50. So does that answer work? Yes, it does. Now let's do the same thing with our second answer, which was negative 123. And again, I have this habit of putting all my parentheses or all my fractions in parentheses, a great habit to get into. So just type it straight in, just how it looks when you've written it down. And we get out positive 50 again. So if we're looking at our equation, both of those should equal positive 50 from the original. So both of these answers work, so you can circle both of them. And then write down problem 3. Should put some, oh, whoops. I thought I was on my pen. Put some little dividers in here. Okay, let's see if we can get this one. What do we need to do first? What's our first step? That's right, we got to get the parenthesis and exponent by itself. So all this needs to be by itself. So what am I going to do first to get that by itself? Not quite. Subtract the 2, then divide. So when you're solving, remember you want to do your order of operations in reverse when you solve. So when I solve, I start with any add or subtract. So let's get rid of that minus 2 first, then we're divide by 2. So always when solving, order of operations go backwards. So we have a 2, x plus 3 to the 3/2 equals 54. Then we divide by 2. So x plus 3 to the 3/2 power equals 27. So add or subtract, multiply or divide. Then, if you think about these steps, we're kind of going our order of operations in order. So next we get rid of the exponent. How do I get rid of that exponent? Good. So we're going to raise both sides through the reciprocal, which is 2/3. So on the left side, it cancels out, and we're just left with x plus 3. And on the right side, we can just type that in our calculator. 27 to the 2/3 power. So make sure that you use the caret key right here. So 27 to the 2/3 power is 9. Do I need to put a plus or minus? Is it an even number on the bottom over here, though? On the first one it is, but the second one's not. So you always look at what you raised it to. So no plus or minus. 3 is not even. So no plus or minus on this one because that 3, what we raised it to, is an odd number on the bottom. So now we've got one more step to solve. What would we do to solve this one? Subtract 3. So 9 minus 3 is 6. And then once we get out our answer, we need to double check. So we're going to type it in, and it should equal on the right side, which we have 56 on this right side. So let's go back to our calculator and type it in. 6 plus 3, 3/2 plus 2. 2, 6 plus 3 to the 3/2. Oops. Now, when you're up here in the exponent, I've almost forgot to, you got a right arrow to get back down to put your +2. So make sure what you type in your calculator looks exactly like what's on your paper. Now, if you have the older calculator, you can just hit +2 and it won't matter. But these newer calculators, make sure you right arrow to get the +2 on the outside. So does it equal 56? Yes, and that's what our problem should equal from the beginning, so that is a good, valid answer. Get some more room for them. All right, let's write down number 4. When you do your homework tonight, it is really important to leave these notes out. So that way you can look for things that are similar to each other. Okay? So really important. Can you wait for the notes to finish up? Okay. If you need to really go, though, you can go. But you can wait because this one's a little different. Okay, so what's our first step? Yeah, you're going to -5. You're exactly right. We got to get this root alone, and we're going to -5 on both sides. So it's going to look slightly different. This side we have our square root x minus 3, but on the right side, what is that going to look like? X minus 5. Now, what are we going to do to step 2? Get rid of that square root. We need to put it to a power of 2. Now, when you put it to a power of 2, can I just square both of these separately? Nope. I got to put a parentheses around it and put a squared. And what happens when you put a squared? You got to write it twice and FOIL it out. So on the left side, we're just left with x minus 3. But on the right side, you got to FOIL and write it out twice. Kind of keep going from there. So let's distribute out. What's x times x? X times -5. -5 times x. And -5 times -5. Then let's combine up those like terms. So keep x minus 3 on the left side. On the right, we have x squared minus 10x plus 25. Now, if you get to this point where notice we have x squared and x in the problem, you have to move everything to one side and then factor it. So you're going to make it equal 0, then factor. I know you guys thought that factoring was gone, but it never goes away. It's one of the biggest things in math. So let's make the equation equal 0. Now what would be easiest is to keep the x squared positive. So let's move the x and the 3 to the other side. So how am I going to move these over? Good. We're going to minus that x and add the 3 and make sure you minus and add to the right terms. So now we have 0 equals x squared minus 11x plus 28. And what kind of problem is this one? Yes, a simple or short trinomial. How do I do short trinomials? You could try to find the GCF, but nothing's in common there. So we do our little scrap work. Very good. What multiplies to be the last and what adds to be the middle? So what multiplies to be 28 and adds to be -11? Good. -7 and -4. Yep, both of them negative will work to make that -11. So remember, once we have the numbers, this is the short way, we plug them back into our parentheses. So x minus 7, x minus 4. Now, it equals 0, so now we set them both equal to 0 and solve. So let's add 7 on this one and add 4 on this one. So I end up getting 2 answers out of this one as well. X equals 7 and x equals 4. It's a pretty long one, huh? And that'll happen a lot when you have x on one side and x on the other side. It ends up being kind of long. Now, once we have our answers, though, look back at what we did on every other problem, which was to do what? Double check. Plug it back in to double check what we have. So I am going to expand over here this way so that way I can see the whole problem. I wrote a little too big. So first, let's double check x equals 7. So it's square root of 7 minus 3. Then a plus 5 is on the outside of that square root. And we want to see if it equals x. So x is also 7. So first check with the 7. Then we'll check with the 4. Is square root of 4 minus 3 plus 5 equal to 4? So we want to plug 7 in for all of those x's. So we can use our calculator. You could also use your brain on this one if you wanted to. Now, after you type in the 7 minus 3, you have to right arrow and put your plus 5. Does that equal 7? Yes. So now we do the same thing with 4. 4 minus 3, right arrow, plus 5. It should equal back to be 4. Does that one work? No, it does not. It should be the same number. So back here, when you get your answer, this one was an extraneous solution. It doesn't actually work. Only the 7 works. So that's why you have to double check them. We did our math correctly. However, sometimes we get out an answer that doesn't work. So this did not equal 4. That equaled 6. But this one did equal 7. All right, last one that we're going to do together is this one here, question 5. And then you guys are going to have like 45 minutes of class time to work, so there'll be lots of time to go through these problems. These last two are definitely a bit challenging. Now, if we follow our steps and follow our rules, the first thing we want to do is get that parenthesis and exponent by itself, right? If you start out, this one has a parenthesis and exponent. Just start out with getting the first one by itself. So what am I going to do with all of this? Add it to the other side. So what happens here with this one is we have 3x plus 1 to the 1/2 power equals 4x plus 3 to the 1/2 power. It all adds over, so it becomes a positive there, so they end up equaling each other. Now, step 2, raise each side to a power to remove that power. So what's going to remove a 1/2? 2 over 1. What happens to both of those powers? They cancel out. Both of them do. So we're left with 3x plus 1 equals 4x plus 3. Now, this is like the type of problems we solved back in January. Way back when. A long, long time ago. What do I do to solve this one? You could subtract the 1. Yep. So we get 3x equals 4x plus 2. Now do the same thing with the x's. So subtract 4x. So we get negative 1x x, or just negative x equals 2. And then we would divide by negative 1. So positive x equals negative 2. And the last thing we want to do is plug it back in to double check. This one's kind of a long one to plug it back into, but it's 3 times negative 2 plus 1 to the 1/2 power minus 4 times negative 2 plus 3 to the 1/2 power. We want to say, hey, does that equal 0? So 3 times negative 2, what was in that parenthesis? I don't remember now. Plus 1. Okay. Plus 1 to the 1/2 power. Don't forget to right arrow. Minus 4 times negative 2 plus 3 to the 1/2 power. Oh, mine is in the wrong mode. Hold on. Y'all did not see that. Let's just type that in again. Did y'all get an error message when you typed it in? That error message means you don't have a real solution there. You don't have a real answer. So what does that mean about this answer? It actually doesn't work. If you get out an error message like that, it doesn't work. So if that doesn't work, then we say no solution. NS will be your no solution. All right, so when you do your homework, you're going to leave these notes out beside your desk, right? All right, and if you want to move tables and make groups, you can. I also put the homework up here. It's a bit blurry, but there it is. So use your steps as you go through to solve these problems.